Algebra, Unit 8, Lesson 5, Notes 5, Factoring by Grouping. Using the distributive property to factor polynomials with 4 or more terms is called factoring by grouping, because terms are put into groups and then factored. The distributive property is then applied to a common binomial factor. A polynomial can be factored by grouping only if all the following conditions exist. There are 4 or more terms. Terms have common factors that can be grouped together, and there are 2 common factors that are identical or additive inverses of each other. So if we take a look here, I've got a couple examples of monomials, binomials, and trinomials. If we look at the 2 terms, AB and AC, we have an A in common. So that would be your common monomial. Over here, 35x to the 4th minus 45x to the 3rd plus 5x squared, they definitely all have x squared, at least, in them. And it looks like I can pull out a factor of 5. So 5x squared would be the common monomial. In the next row, we have common binomials. So in this polynomial, 3x plus 2 is in common with both of those. Similarly, 5y plus z is in common with both of those. It's kind of like factoring out a GCF, but that GCF can be a monomial, binomial, trinomial, etc. In these next 2 examples, you can see the common trinomial is b squared plus 7b minus 5. And in the next one, p squared plus q squared plus 8. So when we factor by grouping, we need to make groups. I have 4 terms. I'm going to throw parentheses around the first 2 terms, and I'm going to throw parentheses around the second 2 terms. Notice that I included the plus sign in the second set of parentheses. Remember, this plus or minus sign, it could be, is a part of this term, BC, so it needs to be included in those parentheses. So look at each group separately. In the first grouping, AC plus AD, they both have an A in common. So I'm going to factor by GCF and pull that A out. When I pull it out, I'm left with C plus D. In the second set, the second grouping, I have a B in both of them in common. So I'm going to bring out a B. It is a positive B, so I need to put plus B. If it were negative, you'd put minus. And then what's left on the inside of those parentheses is C plus D. You should have noticed that I have a common binomial. The binomial that's in common is C plus D. So that is actually my first factor. The other factor is going to be what remains. I have A plus B. So A plus B. And that is how you factor by grouping. Let's do another example. Let's look at letter B. Actually, you know what? Let's look at letter C. Let's throw some coefficients other than 1 in there. Letter C. I'm going to group. Let's color code this one. And do a second group. Again, remember, include that sign. All right. In the first grouping, I definitely have an R in common. And I can also pull out a 4. So the GCF to this blue group is 4R. When I pull out the 4R, I'm left with a Q here and just 2 there. In the second grouping, the GCF is a positive 3, so plus 3. When I factor out that positive 3, I'm left with Q plus 2. Again, notice how I have a common binomial of Q plus 2. That is our first term. And the leftovers will be the second term, 4R plus 3.
Thank you.
Letter D. Okay, so I'm going to group the first terms and group the second terms, again, including that operation or sign in front of that 6C. In the first grouping, it looks like I can pull out a c squared for sure, and the greatest common factor between 30 and 35 is 5. So I can pull out a 5c squared. When I pull that out, I am left with 6c plus 7. Now, over on the second grouping, I have a 6c and a 7, but they're both negative. So what I can do is I can actually pull out a -1, which means I'm really dividing by -1, which will flip those signs. Why do you want to flip those signs? You need to have a common binomial or common something, okay? If I had -6c minus 7, they wouldn't be in common. They have to be identical. So by pulling out that -1, it actually flips the sign for both terms. It's the additive inverse of that binomial, and it gives me what I need. So now my common binomial is 6c plus 7, and the leftovers are 5c squared minus 1. Letter H. Group the first two terms and the last two terms. Okay, in letter H, looks like between 18 and 39, the largest factor I can pull out is a 3. And they both have an a in common. So 18ab divided by 3a is 6b. And 39ac, when I pull that 3a out, I'm left with positive 13c. In this second grouping, again, I want you to notice I have both terms here that are positive. And in the second grouping, both are negative. So I know right away, and you'll be able to recognize once you do a bunch of these, I know right away that I need to pull out a -1, okay? Or just really a negative in general. So when I look at the 30 and 65, the largest value I can pull out or factor would be 5. So I'm really pulling out a -5. They also have a c in common, so pull out that c as well. When you do that, not only does it change the terms, changes the binomial to its additive inverse, it will also help you get your common binomial. So -30bc becomes 6b, positive, and the next term also becomes positive because I pull out that negative, 13c. So your common binomial is 6b plus 13c, and your leftovers are 3a minus 5c. Let's take a look at L. Okay, group your first two and last two terms. The first grouping has a p in common, left with n plus m. The second grouping, I know I have to pull out a negative something because, again, my inside term here, my common binomial here, is positive, positive. And they both have an r in common. Oops. So I'm left with positive n plus m. The common binomial is n plus m. And then the leftovers are p minus r. It doesn't matter which order you write them in. You could write them p minus r and m plus m, and that goes for any of these because these two binomials are being multiplied together. Remember, multiplication is commutative, which means it doesn't matter which order you multiply numbers or terms together. So you could write them either way. Go ahead and finish up the rest of these and be careful, watch those negatives.